Good day once again, class. So for today's presentation, I will be discussing with you on how we are going to find the confidence interval, or you are going to estimate a population parameter, in particular the population mean based on the samples. And this is what we call now the confidence interval for a large sample estimation. So when we say large sample estimation, class, so we are considering that the sample size is 30 and above. Okay, it could be hundreds or thousands, but not less than 30. Okay, so before we begin with the estimating a parameter using the population mean or the sample mean to estimate the population. So just to give you an idea, class, on what is an estimator. Okay, so there are two types actually typically of estimators, and when we say an estimator, class, this is a rule. Usually it's a formula that tells us how to calculate an estimate that is based on the information in the sample. In other words, class, when we collect sample data, we usually solve for the mean or the standard deviations, or even sometimes to the extent we are using the percentage if we are going to count the number of times. Okay, so those are the data that we usually describe based on the sample. So one type of an estimator is what we call the point estimator. So this is simply a single number that is being calculated to estimate a population parameter. So either we are now estimating a population mean, or we are estimating a population proportion or a percentage. Now this calculation is called the point estimator. Sometimes, of course, other names is a point estimate. Okay. And of course, the resulting number is what we call the point estimate. So examples of point estimate, class, is the value of your mean, which is a sample mean, the value of your median, that could also be the case, the value of your percentage or proportions when you have a survey by simply counting the number of times in the survey that it's the success, as what we call it. So if that will be the case, class, then there is no need for us now to estimate or make now an interval. However, whatever is the result of the mean based on the sample, that could be our estimate also to estimate the population parameter. The other type is what we call the interval estimations. And this is our concern for this lessons, class. So there are two numbers that are being calculated in the interval estimation. And this calculations is what we call the interval estimator, and the resulting pair of numbers is what we call the interval estimate or the confidence interval, which is our focus for today's lesson. So when we say interval estimations or a confidence interval, so we are looking for those two values. Okay, these are range of values that we can capture where lies now the true population parameter. Could it be the mean, or could it be the percentage? So just to visualize it, class, so given that our sample data is normally distributed, and the true value can be approximated or can be solved through an estimation or estimated now, given a sample, the mean or the proportion will be at the center, then there is what we call a margin of error to the left of the point estimate and to the right of the point estimate. All we have to do, class, is we're going to add and subtract it from the point estimate, okay, that is being described in the sample data. And when we say margin of error, we can choose any from this one. So we have the 1.645 times the standard error as a one margin of error. You could also have the 1.96 or the 2.575. Now, what are these values, class? These are actually your critical values that is based on your confidence level. Okay, so in the few slides, we can see now, okay, the different critical values that corresponds to the uh, confidence level. So in a population mean, class, so if you're going to estimate a population mean, so when we say population mean, uh, we are going to estimate the population parameter in terms of the mean value for any quantitative populations, then the point estimator, which is the sample mean, is unbiased with, of course, the standard error or the SE that is estimated by this formula. So the standard error class is not an error. This is just a term that we use in the statistics that describes now the deviations of the different means, okay, from one another. So in other words, if you're going to take a sample, you solve for the mean, record that one, then you take another sample, then you solve for the mean, then you record that one. So every time that you take a sample class, then if you compare now the differences of their means through its variations, the result class is what we call the standard error. And of course, your SD stands for the standard deviations. Now, this is only applicable class if the margin of error is can be computed when there is now a large sample. So as mentioned earlier, the sample size should be at least 30 or more. Then the margin of error can be computed using now the critical value that we choose based on the confidence level times the standard error, which is denoted by this formula. Okay, or we can simplify this as your critical value times the standard deviations divided by the square root of your n, where we have here plus and minus indicating class that we need to add and we need to subtract it from the point estimate that we choose, in this case, the sample mean. So again, class, from the previous topics that we have, we always use the mean and the standard deviations because these are the two most important measures of this description rather. So when we construct a confidence interval class, so it's simply your point estimate or the point estimator. So typically, because we are estimating the population mean, then the point estimate that we are using is the sample mean or your X bar. Then plus and minus your standard, the margin of error. So this is simply the product of the critical value times the standard error as we um, uh, see it. So the common, okay, confidence intervals or CI are the following class. So these are common. Actually, the most common is the 95%. So seldom that we use the 80% class. However, there are times that we use the 80%, but most often than not, we use the 95%. There are also times that we use the 90% confidence level. And when it comes to medical researches or to some, let's say, health-wise, okay, pharmaceutical researches, then we usually use the 99% confidence level. So if you choose the confidence level class to be 90% or 95% or 99% confidence, there is an equivalent critical value. And these critical values are the ones that we need to input in the margin of error before we multiply it now to the standard error. So this will be changing from time to time based from your confidence level that you choose. Now, if there is no confidence level indicated class, so that means that you have to use the 95% confidence level with a critical value of 1.96. Okay, so be mindful of that one, class. So to summarize now our formula for the confidence interval, so as I said, these are now the formula that we use. So this is used only for a mean, population mean parameter. So we have here the different confidence level with the corresponding confidence interval. So here you have your X bar class. This is actually the sample mean plus and minus your different critical values corresponding to the confidence level that you choose times the standard error of the mean, which is given by the ratio of the standard deviations to the square root of your sample size, provided class that your n or the sample size is at least 30. Okay, so we can actually solve this one directly if you want to, or we can solve it parts by part so that you can have a better way of looking into how we solve for the confidence interval. So to visualize, class, the confidence interval is that the whole area supposedly based on the sample, okay, is 100%. So when we say at 5%, that means the confidence level is 95%. So we only uh, going to find the middle 95%. So if your confidence level is 99%, then it's only the middle 99%. you will notice, class, that there will be a lower confidence limit and a upper confidence limit. This is what we are going to solve, class. What will be now the lower limit and the upper limit, because this will give us now the range of the uh, interval where we can, okay, identify where the true mean lies, okay, at a certain confidence level. Okay, so in other words, class, we are already forecasting a population parameter based on a sample. So just an example, class. So say, for example, you want to find out what are, okay, what are the grades of all students in a certain subject. So say, for example, the grades in mathematics. Now, since it will take us time, class, to get all the details, all the students in the university enrolled in math, that could take time. So what we do is to estimate it only. However, how do we do that? We just get a sample class. Okay, you might getting only one section who are enrolled in math class, then you solve for the mean grade, and with the standard deviations, then based from the mean and the standard deviations, we can now approximate the entire grades of all students in mathematics. Okay, so that's how we use the confidence interval, class. So in other words, what will be the mean grade of all the students in the university, given only the sample value, class. Okay, so that's the purpose of the population estimation using the mean. So let's have here an example, class. Okay, so suppose scores on exams in mathematics in University of Baguio are normally distributed with an unknown population mean. So what you want, class, is what will be the mean score of all the students in University of Baguio who are taking math. So since we do not know that value, so what we do is a random sample of 50 scores is taken and has a sample mean of 68 points with a standard deviation of 3 points. At 95% confidence level, estimate the true population exam scores in mathematics in the University of Baguio. So basing only on the sample size, class, with the sample mean, which is the point estimate, and the standard deviations, and there are only 50, then we can use this data, class, to estimate the population mean. In other words, we are now considering what if all the students in the University of Baguio are taking the exams, what could be the mean score? Okay, so that's how we uh, solve this one, class. Okay, so first we identify the given data. So our N here, there are 50 scores because there are only 50 cases that we sampled. Based on these 50 scores, the mean score is 68 points. So this is what we call the point estimate. And the standard deviation is 3 points. Now, we are asked to establish a confidence level, okay? To establish a confidence interval, or to estimate now the true population exam scores at 95% confidence. So you have to find out or to know what is the critical value that corresponds to 95% confidence. So as seen in the table, class, earlier, so we have 1.96. So that's very important, class, now to have a copy of the different critical values with the confidence level. Okay, so we use the 1.96 as a critical value because we are given 95% confidence. Okay, so our margin of error at 95%, okay, confidence would be the 1.96 times the standard error. And the standard error here is given as the ratio of the standard deviations to the square root of your n. So since we already identified the appropriate formula for the margin of error at 95% confidence, then we have to carry this one, class. We are going to substitute the needed informations here. So again, your standard error is your standard deviations divided by the square root of n. Your 1.96 as a value or a critical value, this is based on a 95% confidence level. So the standard deviation is 3. The n, the number of cases, is 50. So if you're going to take the square root of 50, you divide it from 3, then we have the 0.424. So Typically, class, we just round our answers to 3 or 4 decimal places. So up to 3 decimal places will do. Then we multiply this to 1.96. Then the result, class, is the margin of error. So which is 0.832. Now this is what we need, class, so that we can add this 0.832 and we can subtract this from the point estimate of 68 points. And that would be now the lower and the upper limit of the confidence interval. So with the margin of error of 0.832, then we can now create the confidence interval. So the confidence interval, class, again, is your point estimate, which is the sample mean, plus and minus your margin of error. So this one, class, you don't have to resolve again because this is already solved equivalent to 0.832. So we already have here the value. So you notice here the addition and the subtraction. So you have the lower and the upper limits. So the lower limits, class, is to subtract 68 by 0.832, and the upper limit is to add 68 to 0.832. So round your answers to a whole number because these are scores or points. So from 67.168 as the lower limit, that remains to be 67, while 68.832, that would be rounded to 69. So based from the mean or the sample mean of 68 points from the 50 scores, we can now say that the mean, okay, score of all the students in the University of Baguio taking mathematics will range only, class, from 67 to 69. With how many percent confidence? That would be 95% confidence. So therefore, if you're going to interpret now the results based on the problem, so with 95% confidence, the true population exam scores in mathematics in the University of Baguio is between 67 to 69 points inclusive. In other words, either it's 67, 68, or 69. So this is what we are expecting, class. Basing only from the samples of 50 with a mean score of 68, we can now estimate the entire, okay, exam scores, the mean exam scores of all students who enrolled in mathematics in University of Baguio. And it make our computations or tawag dito, class, o gathering of data easier because we are not going to take all the necessary scores. Imagine, class, if there are 13,000 students who enrolled in mathematics, you could just imagine you add all the scores of the 13,000 divided by 13,000, whatever is the result will be the population mean scores. However, if you're just going to take a sample, you estimate it, and there we go. We only have few computations, then we can now estimate the population mean. So at 95% confidence, so we are now saying that the population exam scores in mathematics is ranging or between 67 to 69 points inclusive. The word inclusive, class, indicates that 67 and 69 are part of the solution. Okay, so that's the first example, class. Okay, so another example here is, ayan, so yung mga mahilig sa pizza. So suppose the average pizza delivery times in terms of minutes are normally distributed with an unknown population mean. Okay, so how many times that uh, you ask for the delivery of a pizza regardless of the delivery person. It could be Grab, it could be Panda, okay? So a random sample of 75 pizza delivery restaurants is taken and has a sample mean delivery time of 36 minutes with a standard deviation of 6 minutes. So find a 99% confidence interval for all pizza delivery time. Now, this one here, class, is only based on 75 pizza delivery. So if you're going to consider, what if you're going now to consider all the deliveries of pizza in that area? So what would be our expected time, okay, to arrive? Okay, so we are going again to identify the given data based on the problem. So in this case, there are only 75 pizzas as our sample. Then the point estimate, which is the sample mean, is 36 minutes. So that's the mean time based from the 75 pizza delivery, okay, before it reaches the destinations with a standard deviation of 6 minutes. Then we are asked to find an estimate with 99% confidence. So when we say 99% confidence class, then the critical value to be used is 2.575, not the 1.96. The 1.96 class is for 95% confidence. For the 99% confidence, we use the 2.575. Okay, then, of course, the margin of error at 99% confidence, we have to use the 2.575 multiplied to the standard error. Again, the standard error is or can be solved using now the standard deviations divided by the square root of n. Okay, so we start with the margin of error. So again, so you are guided. So 2.575 at 99% confidence. Then substitute the standard deviations of 6 divided by the square root of your n, which is 75. Of course, the standard error is 0.693. Then multiply to the critical value. The result class is the margin of error. So this is the one that we need to add and subtract. This is in minutes, okay, from the mean of 36 minutes. Okay, so once we already have the margin of error, then we are going to apply this by substituting into the confidence interval formula. So the mean is 36. This is the sample mean or the point estimate, plus and minus the standard, the margin of error rather of 1.784, which we solve. Then we subtract and we add again. So the lower limit will be 36 minus 1.8, sorry, 1.784 will give us 34.216, or in whole number, this is about 34 minutes, while the upper limit is 36 plus 1.784, that would be 37.784 minutes. Rounding that to a whole number class will give us 38. So from the sample of 36 minutes, we are going now to, okay, estimate if all the pizzas will be delivered, in how many minutes will that be, and that would be our answer here. At 99% confidence, we now know that the pizza will be delivered to its destinations between 34 to 38 minutes, inclusive class. So our interpretations would be like this class. So with 99% confidence, the true delivery time for all pizza is between 34 to 38 minutes. There should be an inclusive word here, indicating that in the pizza delivery class, you are expecting that it would be 34 minutes or until 38 minutes. Any time that is beyond 34 to 38 minutes class, that is already outside the confidence limit. Okay, it could be an error, or if that will be true, then there is already a shift of time. Okay, but this time we are just uh, looking into the parang hindi naman siya future class, but we are estimating only based on the sample size. Okay, ayan. So that's how the use of estimation class is all about. Okay, so another example. A national poll surveyed 1,000 Filipinos living in cities to gauge their levels of discretionary expenses. Now, when we say discretionary expenses class, this is an expense or a cost that you spend, okay, at a certain time that is not important or essential for the operations of a home or a business. In other words, if your the amount of money that you are spending because of rentals, because of gasoline that you need, so that if you have a car, so those are not part of your discretionary expenses. Okay, as long as these are not expenses that has something to do with the operations of a home or a business. So in other words, this could be any expenses class, like buying an ice cream, buying your food outside, okay, or dining outside your house, okay, or spending unnecessary, okay, or things, okay, mga ganun class. So these are what we call discretionary expenses. So for these sampled households, the average amount spent was 10,175. We do not know class if this is per week, this is per month, with a standard deviation of 5,225 pesos. So these are based from the 1,000 Filipinos who are living in cities. So Filipinos not living in the cities are not part of this one. So we cannot estimate their expenses for that. So at 90% level, estimate the population discretionary expenses of all Filipinos living in a city, because the sample class is only from the cities. Okay. So again, what are the data from the problem given? So there is a sample size of 1,000 Filipinos. The point estimate is the sample mean of 10,175 as the discretionary expenses with a standard deviation of 5,225. And we are only asked to find a confidence interval based on 90% confidence. So if it is a 90% confidence class, the critical value is 1.645. So you see the changes class of the critical value based on the confidence level. So if it's 95% confidence, then the critical value is 1.96. If the confidence level is 99, the critical value is 2.575. However, in this problem, the confidence level is 90%, then it would be 1.645. Okay, so our margin of error now will simply be plus and minus 1.645 times the standard error given by this formula class. Okay, so if you want to substitute this directly, but you need also the other data. So the standard deviation is 5,225. The number of cases or sample is 1,000. So you have to take the square root of 1,000. Then you divide it from 5,225. So I have here 154.229. So I just rounded class to 3 decimal places. So this is the value of the standard error. Multiply this with the critical value. The result is your margin of error, which is 271.802 pesos. So this is now in terms of pesos class. So therefore, we already have our margin of error. Then we can now create our confidence interval. So the confidence interval again is your point estimate, which is the 10,175 plus and minus the margin of error that we just solved to be 271.802. Then we subtract it and we add it from the sample mean and we have the results. So I usually round the answers class to a whole number. Okay, and of course 9,903.198 could be 9,903 only, while 10,446.802 can be rounded to 10,447. So this is already the estimation class that based only from the 1,000 cases, okay, with the sample of 10,175, we can now say at 90% confidence that the true, okay, population discretionary expenses of all Filipinos in a city, living in a city class, would be between 9,903 up to 10,447 pesos with 90% confidence class. So, dito class, ito na yung parang ina-approximate na natin na what if all Filipinos will be considered, okay, living in the city, and what will be their discretionary expenses would be. So, ito na yung ina-expect natin class at 90% confidence. So, from 9,903 up to 10,447. So that would be our expectations if we are talking already the population parameter. Okay, so that's how we use class now the formula to estimate the population parameter based on the sample mean. So this is what we call estimation of large samples using the population mean. And of course, this already ends my presentation. So again, I'll see you in the next presentation class. Okay, so have a good day. Bye bye, everyone.